All right. Today we'll be looking at periodic table and atomic number. So we have already discussed earlier the concept of the periodic table, the arrangement of elements in the periodic table, what determines what the group and element belong to, which is the valence electron or the atomos electron, and what determines the period it belongs to, which happens to be what? The number of energy level or the number of shells. Yeah, the highest energy level, the number of shells. Determine the period an element belongs to, what the number of electrons in the atomos shell determines the group an element belongs to. And we have established that the atomos electron determines majorly, or the electronic configuration of the atom determines majorly the main properties of the atom, while the atomos electron determine the chemical properties. See, when elements goes into reaction, it is the atomos electrons that are involved majorly. So it is what determines the chemical reaction. Now we're going to look at certain atomic properties and their variation in the periodic table. One, we have atomic size, ionization energy, electron affinity, electronegativity, and the electropositivity. We'll be looking at them one after the other per class. So today we're discussing atomic size. Atomic size. It is actually not easy to define, say this is actually the size of the atom easily. But with X-ray and electron diffraction, it is possible to determine what the size of the atom is. Majorly, we can say if you have two covalently bonded atoms, the diameter of these atoms will be the distance between the nuclei. That's how to measure the size of the atom. But our interest today is the variation of this size of the atom in the periodic table. How does it vary? Now, let's look at these configurations. Group 1, we have hydrogen 1. So this is why in group 2, we have helium 2. Now in group 1 again, we have lithium 3. Here we have magnesium, beryllium 4. In period 2, please look at your periodic table that we just arranged. This is group 1, group 2, period 1, period 2. In period 3, we have sodium 11, 1, 2, 1, 2, 1, 2, 1, 1, 2, 1, 2. Why in period 3 here we have magnesium. Magnesium is 12. We have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Let's stop here. Now, we want to look at the variation of the atomic size in the periodic table. As we move across the period from left to right, what happened? As we move across the period from left to right, let's look at boron in group 3. Boron in group 3, boron is 5. We will have 1, 2. 1, 2, 3. That is boron in group 3. Now we have in group 4, we have carbon 6. 1, 2, 1, 2, 3, 4. Then in group 5, we have nitrogen 7. 1, 2, 1, 2, 1, 2, 1, 2. So you see, as you move across the period from left to right, you see that the number of electrons is increasing by 1. Here we have 1 electron in the atomos shell, 2 electrons in the atomos shell, 3 in the atomos shell, 4 in the atomos shell, 5. So the electron is increasing by 1 as you move from left to right. As the electron is increasing, also know that the number of protons are also increasing. So the number of protons determine what we call the nuclear force. And in the arrangement of electrons around the atom like this, you know that there are two forces that are in operation: the nuclear force and the repulsive force. The nuclear force is a force exerted by the nucleus of the atom, while the repulsive force is a force exerted between the electrons due to their same what? Charge. You know electrons are negatively charged. Like charges do what? Repel. Unlike charges do what? Attract. And since all of them are negative, there's going to be a kind of repulsion among them. So, as you move from here to, you see that the number of electrons per share is increasing. Also, the number of the nuclear force is increasing because the number of protons is increasing. And because the nuclear force is increasing, it has been established with evidence that the force of the nucleus, as we move from left to right across the period, is much more than the force, the repulsive force that is exerted by the electrons. So the nuclear force tends to have more effect than what? The repulsive force. And so it tends to pull the electrons in the atom shell towards itself. Because, you know, like charges repel. And because the protons in the nucleus are positively charged, they have the tendency to what? Attract the electrons to themselves. And because of that, as we move from here, as the electron increases, the effect of the nuclear force becomes higher and higher. Because they are what? In the same shell. Not that this increase is happening in the same shell or the same energy level. So the distance from the nucleus for each of these shells is not different. From here to here is just one shell, 1, 2, 1, 2. So the distance is not different. So the effect of the nuclear force counterbalances what? The effect of the repulsive force. And so because the nuclear force will be dragging or drawing the electron towards itself, as we move from left to right, the atomic size decreases as we move from left to right. Now, as we move down the group, what happens? As we move down the group, we see that from here to here, we have one shell here, 2 shells here in period 2, 3 shells in period 3, 4 shells in period 4, 5 shells in period 5. So as we move down the group, see that the number of shells keep increasing by 1. If you can picture these shells like a fence, you see that the shells that are increasing will tend to shield the effect of the nuclear force from the external, from the outermost electrons. And so because of the internal screening by the shells or the energy level, or the electrons in the energy level within, the effect of the nuclear force is not really felt that much by the electrons in the outermost shell as we move down the group. And because of that, as we move down the group, we say that you see that the atomic size will what? Increase down the group. Down the group, atomic size increases. And this is because as we move down, even though the nuclear force is increasing, the effect of the nuclear force is not that fair because of what? Internal screening and the repulsive forces of the electron stopping the nuclear force from getting across to the outermost shell. And the number of shells as they are increasing, the more what? The internal screening. So the internal screening here will be less than the internal screening here. And so the size here will be bigger what? Than the size here. Because the nuclear force here will draw this one closer than it will be able to draw what? This closer. Because there are what? How many shells here? 1 here. Here there's no distance between here and here. Here is just this shell. And then you have what? The nucleus. This is the nucleus. And so in period 4, you know there are what? 1, 2, 3, 4. 4 shells. There will be 3 screening you need to do before you get to what? The outermost shell. In period 3 here you have 1, 2. You have to screen, the nuclear force have to pass through 2 shells before you get here. And all of them will have some screening effect on the nuclear force. And that is why you see the effect will not be felt completely that much, like when there is only 1 shell, and like when there is no shell at all. So as we move down the group, the effect of the nuclear force decreases and the atomic size what? Increases. So down the group, atomic size does what? Increases, while across the period, atomic size decreases. What does that mean? As we move from left to right, it implies that electronegativity, which is the ability of an atom to accept electron will do what? Increase. Wind down the group, the ability of an atom to give out electron, which is electropositivity, the opposite of electronegativity, will do what? Increase. So that is it about what? The atomic size and what? The periodic table. Please do not forget to leave your contribution or question in the comment section. And if you're on YouTube, do not forget to subscribe.